Good evening, everyone. This is Group 12 here to present the project on the topic Naive-based classification. The group members are Mihir, Devika, Jinyao, myself Smriti, Amit, Mukesh, Rahul, and Sri Lalita. Now, the motivation behind choosing classification algorithm. The main purpose of classification algorithms is to make sense of information and extract values from large data sets that contain both structured and unstructured data. While working with large volumes of unstructured data, it only makes sense to try to partition the data into different groups based on their relevance before attempting to analyze them. Using classification algorithms, text analysis software can perform things like sentiment analysis to categorize this unstructured text into polarity of opinion, say positive emotions, negative emotions, etc. Sentiment analysis is used to study subjective information such as survey responses, online behavior, and social media behavior, etc. Now, there are three major methods to define a classification algorithm. A is to model a classification rule directly, for example, using k-nearest neighbors. B, model the probability of class memberships given input data, say using perceptron with a cross entropy cost. And C, make a probabilistic model of data within each class, for example, using Naive-Bayes, and that is what our topic focuses on.
Hi, my name is Xinyao Yi. I will introduce page 3 and page 4. Firstly, I will give the definition of classification. Classification is a technique where we categorize data into a given number of classes. The main goal of a classification problem is to identify the category or class to which a new data will fall under. When we have some data, by using the classifier, we can correctly classify this data according to some characteristics. Classification can be performed on structured or unstructured data. What is the steps in the classification model? The first step is to initialize the classifier to be used. The second step is to train the classifier. All classifiers in scikit-learn uses a fit-xy method to fit the model for the given train data x and the train label y. The third step is to predict the target. For a given unlabeled observation x, the predict x returns the predicted label y. The last step is to evaluate the classifier model. At last, my question is, how can we evaluate the classifier model? The answer is precision, recall, and specificity are three major performance metrics describing a predictive classification model. Thank you.
Hello all, my name is Devika Unnikrishnan and I'll be talking about the Naive-Bayes classifier. Naive-Bayes classifier is a probabilistic machine learning model that's used for classification tasks. It assumes that the presence of a particular feature in a class is unrelated to the presence of any other feature. Some of the advantages of the Naive-Bayes classifier is that it requires a small amount of training data, and Naive-Bayes classifiers are extremely fast compared to other more sophisticated methods. This is the formula of the Naive-Bayes classifier. P of C given X is the posterior probability of a class C given predictor X. P of C is the prior probability of the class. P of X given C is the likelihood, which is the probability of the predictor given the class. P of X is the prior probability of the predictor. So the question is, given this data, what is the probability that if a fruit is long, sweet, and yellow, that it is a banana? So we can calculate these three parameters and get the answer. That is probability of likelihood, class prior probability, and prior predictor probability. Once we calculate all these three values, we will get the answer as 0.969 as per the formula. Thank you.
Hello, my name is Mihir and I will be walking you through a simple example explaining how naive-Bayes classification works. So in this particular example, we are trying to predict whether a player will play a sport, let's say golf, based on some weather conditions. Here we have three features or our weather conditions, which are weather, temperature and humidity. So here weather can be sunny, overcast and rain, temperature can be hot, mild or cool, and humidity can be high or normal. So from this dataset we will compute our prior and posterior probabilities for naive Bayes, and using them we can predict the class for any new instance. So moving on to the next slide, we first calculate the prior probabilities of our classes, which are yes and no, and as it can be seen from the slide, it's 6 out of 9 and 3 out of 9 respectively. Next we calculate the posterior probabilities for every feature, that is, given play is yes, what is the probability that the weather is sunny or the temperature is hot. So we do this for every feature. So now that we have calculated the probabilities, we can plug them in our formula and predict the class for a new instance. So let's consider this instance X, where weather is sunny, temperature is cool and humidity is high. So these are our probabilities from the learning phase, and we just put them into our formula. So we basically multiply all our posterior probabilities, and finally we multiply the prior probability of that class. So we get the probabilities for two classes yes and no, which can be seen from the slide. And so here the probability for no is more than yes, so the predicted label in this case will be no.